look at, hi guys. We're going to look at notes for 8.7, which is vectors. So in this problem, it says use a ruler and a protractor to draw each vector. Include a scale on each diagram. So what I did is went ahead and just copied the images from it since most of us don't have access to a ruler or a protractor. So for part A, we have the vector m is equal to 15 miles per hour at 140 degrees to the horizontal. Using a scale of 1 centimeter equal to 5 miles per hour, we're drawing and label A 15 divided by 5 or 3 centimeter arrow at 140 angles to the horizontal. So they set the ratio to 1 centimeter is equal to 5 miles per hour. And the reason for this is most rulers are in centimeters. And so that's what they drew here. For B, they used a scale of 1 inch equal to 25 pounds. Then they labeled an arrow doing 55 divided by 25, or about a 2.2 inch arrow with 55 degree west. So they did this so they were able to draw this to a smaller scale instead of drawing everything very large. So let's go ahead and look at some concepts here. We have the concept of vector addition. Okay, so to find the result of vector A and vector B, use one of the following methods. So you could either use the parallelogram method or you can use the triangle method. And we're going to see those in the next example. So example 2, we're going to use both methods for the vectors. So subtracting a vector is equivalent to adding its opposite vector. So we're going to copy vector C and vector D, and we're going to draw the negative version of vector D. Okay, so we have vector C and the negative version of vector D. So look, now it's going down instead of up. We're going to complete the parallelogram. So dot, 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 dot. And we're going to find this. This right here is C vector minus D vector. So that's how we do parallelogram method. Now we're going to do the triangle method. Copy vector C and D and draw the negative version of vector D. Okay. Translate it so that its tail touches the tip. So the tail is the end part of it without the arrow, and the tip is with the arrow. Draw the result vector from tail to tip. So this part. This part would be C vector minus D vector. Okay. Now let's look at example 3. We're going to write the component form of CD. So to describe a vector with any initial point, you can use the component form, x, y, which describes the vector in terms of its horizontal component x and its vertical component y. To write the component form of a vector with initial point x1, y1 and terminal point x2, y2, we have to find x2 minus x1 and y2 minus y1. So that's what we're going to do. So looking at our graph, x2 is 4 minus x1, which is 0. y2 is 1 minus y1, which is negative 1. So we have 4, 2. That's our answer. Let's look at example 4. Find the magnitude and direction of the vector. The magnitude of a vector on the coordinate plane can be found by using the distance formula, and the direction can be found by using trig ratios. So first, we're going to use the distance formula. So the distance, or the magnitude, of vector r is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we have negative 4 minus 0 squared plus negative 5 minus 0 squared. So this is the square root of 41, or about 6.4. Now we're going to do tangent of theta, which is just an angle that we need to find, is equal to 5 over 4. So in order to do this, we do tangent inverse of 5 over 4 is equal to theta. If we type that into our calculator, we get 51.3 degrees. So that means the direction of vector r is going to be written as 180 degrees plus 51.3 degrees, which is 231.3 degrees. So the magnitude of r is about 6.4 units in the direction of the angle of 231.3 degrees. So this is important and this is important. Okay. Let's look at a key concept. If vector AB and vector CD are vectors and k is a scalar, then the following are true. So we're going to talk about scalar addition, subtraction, and multiplication. Let's look at example 5. For each of the following, it gives us vector r, s, and t. And then we can check our answers graphically. And I already just copied down all the checks so you can see it, so we didn't have to draw it. So r plus t. So vector r plus vector t is the same as saying 3 plus 1, comma, 4 plus negative 2. So this is 4, 2. Okay, s minus r. So s minus r is equal to s is 5 minus r, which is 3, and then negative 1 minus 4. So this is 2, negative 5. Let me write that negative 5 better. There we go. Now, 2t minus s. So first we have to do 2 times t, and t is 1, negative 2. So this is equal to 2, negative 4. And then we subtract. So we have 2 minus 5 and negative 4 minus negative 1. So this is going to be negative 3 and 1. That's not right. Negative 4 plus 1 is 3. Negative 3. Okay, easy. Okay, let's look at the next example. Okay, we have Trey is paddling north in a kayak at 7 feet per second. The river is moving with a velocity of 3 feet per second due west. What is the result speed and direction of the kayak? So first we have this diagram. So this diagram right here. We're letting r vector represent the answer. The component form of the vector representing the paddling velocity is 0, 7. And the component form of the vector representing the velocity of the river is 3, 0. The resultant vector is 0, 7 plus 3, 0. So the r vector is going to be 0, 7 plus 3, 0, which is equal to 3, 7. Okay. Now we're going to use the distance formula and then the to find the speed, and then we're going to use trig to find the direction. So we have the magnitude of r is equal to the distance. So we have negative 3 minus 0 squared plus 7 minus 0 squared. Well, this is equal to the square root of 58, or approximately 7.6. Now we do tangent of theta is equal to 3 over 7, which we use the arc tangent to find theta. So theta is equal to the tangent arc of 3 over 7, which is equal to 23.2. So that means that the direction of the vector r is about 23.2 west of north. Therefore, the resulting speed of the kayak is about 7.6. So the speed is 7.6 feet per second at angle 23.2 west of north. And then that concludes the notes for Unit 6.